Okay, so let's see how a Taylor polynomial differs from a Maclaurin. So the biggest difference is that we are no longer centered at the origin like we were with a Maclaurin. We're now going to be centered at 2 for this example. So that means we're going to have some small changes to our formula. But the process is going to feel a lot like what we did with our Maclaurins. So we have some function 2 over x squared, or we can think about this as 2 times x to a negative 2. That's going to be helpful for when we're taking derivatives. We're being told how many derivatives we need, so we're going to the fourth derivative, and we are now going to be centered at 2 instead of 0. So we're going to find the Taylor approximation to the fourth degree, so the fourth derivative of this function centered at 2. Let's start like we did for the Maclaurin, which is we have our function, and let's evaluate that where we are centered. So we're going to get 1/2. Now we're going to need to know what our first derivative is and evaluate that at our center of 2 instead of the 0 that we did with the Maclaurin. So remember, this is really the same thing as 2 times x to the negative 2. So we can do a power rule. So this will now be a negative 4x to the negative 3. So in other words, when I'm evaluating this, I now have negative 4 over 2 to the third power. So negative 4 over 8 will give me a negative 1/2. Our second derivative. All right, we're now going to have a negative and a negative, so that means we're going to have 12x to the negative fourth power. So when we go to evaluate this, we really have 12 over 2 to the fourth power. I'm going to pop this in my calculator really quick just to save some time. And I don't have a digital camera or calculator on my tablet, so I'm just doing this with a handheld. And let's change that. So we're going to end up with 3/4. All right, third derivative, and then evaluate it at 2. So now we're going to have a negative 48 x to the negative fifth. So now a negative 48 over 2 to the fifth. So again, I'm going to put that in my calculator by hand. So negative 48 over 2 to the fifth. And I'm going to end up with a negative 3/2. And our last derivative, we're now going to have that negative 5 and 48 get multiplied together, so that's 240. And x to the negative sixth power. So now we have 240 divided by 2 to the sixth. I'm going to put this in my calculator again real quick. And I'm going to get 15 over 4. Okay, so now we have all of our leading coefficients that we need to set up our Taylor polynomial. So, Taylor polynomial, degree of 4, so fourth derivative of x, will be equal to our first term, our f of 2, which is 1/2. Plus, now we're going on to our first derivative. There's a negative there, so I'm going to change my plus to a minus. Our leading coefficient is 1/2. Now, before we would have had x to the first power over 1 factorial, but that was because it was x minus 0. This is now x minus c, and my c was a 2. This is to my first power over 1 factorial, which of course doesn't change anything because 1 factorial is 1, but I'm putting it there to emphasize. All right, then we're on to the next one. So plus 3/4 is our leading coefficient. We're still going to have our x minus 2, but now we're onto a second derivative, so it's squared. And over a 2 factorial. The next one we have a negative, so I'm going to have a minus. We'll have our 3 halves. We'll still have our x minus 2. But now we're onto the third derivative, so it's cubed and a 3 factorial. And the last one is 15 over 4. So plus 15 over 4, x minus 2, I'm onto my fourth derivative, and 4 factorial. All right, so there's my initial setup. Now I just need to go ahead and clean up these factorials and these products. All right, so we have 1/2 minus 1/2 x minus 2. You're not going to distribute anything. You're going to still leave things with parentheses. Same thing over here. So we're going to have our 3/4. We have this x minus 2, but we have a 2 factorial. So 1 times 2 is 2. And while I'm at it, I think I'll just go ahead and start cleaning up for the next line. So over here, we're going to have 3 over 4 times 2, which is 8, and x minus 2 squared. Then we're on to the, oops, there's a minus sign there. We're on to the next, which will have a minus. So we have 3 halves, but we also have 3 factorial. So 1 times 2 times 3, which is 6. So this is now 3 over 12, which will reduce, right? 3 over 12, so they both go in by 3, so 1/4. X minus 2. I do not know why these are doing these little squirrely, so please ignore that. All right, and we're on to the last one. So we had 15 over 4. We have our x minus 2 to the 4th, but we needed to go ahead and simplify 4 factorial. So 4 math, go over to probability, and number 4 is your factorial, and that is 24. So really we have 15 over 4 times 24. So I'm going to go ahead and put that in my calculator. So 15 divided by 4 times 24. And I'm going to turn that back into a fraction. And that is going to reduce to 5 over 32. All right, so here is our cleaned up. I know it doesn't look clean, but there's our cleaned up version of our Taylor polynomial to the 4th degree or 4th derivative of this function 2 over x squared. So you're going to do the same thing with 27 through 31 in the packet. There's 3 of those. And you're going to do those as Taylor polynomials, centered by wherever they tell you you are centered by. Right? So don't just automatic pilot and put in a 2. That 2 came because that's where I was centered at. Right? But when we look at yours, you can see you're going to be centered at 1, 4, and 2. Okay?